Namaste. Welcome to the next video of Machine Learning Techniques course. In this video, we'll study fifth and the last component of the linear regression model, which is evaluation. We use root mean squared error or RMSE as a way to measure the performance of the linear regression model. We can measure this performance across different data sets. Usually, we report this measure on validation and test data set, but we can also calculate this particular measure on the training set. So RMSE is derived from sum of squared error or the loss. You remember that sum of squared error is the square of difference between the predicted value and the actual value of the label, and we multiply that quantity with half for mathematical convenience in the optimization. So RMSE is defined as a square root of 2 over n times SAC. Now when you substitute this particular formula for SAC in this particular formula, this particular 2 and this 2 cancels each other and we get 1 over n times SAC. If we write this in a non-vectorized form, this might be easier for all of you to read. This is 1 over n sum of square of difference between the predicted label and the actual label. Got it? So RMSE uses square root to compare the error on the same unit and same scale as that of the output label. And we divide by n over here, which is the size of the data set that enables us to compare model performance on data sets of different sizes. Now that we know all 5 components of linear regression model, let's do a quick recap. So we have 5 components: data, model, loss function, optimization procedure, and evaluation. Let's see what all these components have, first in plain English and then with mathematical formulas. So the training data in linear regression consists of features and labels. Labels have a special property that they are real number in case of linear regression. We use linear combination of features to obtain label. So linear combination of features is the model used in the linear regression. We use sum of squared error or SSE as a loss function. We divide this SSE by half for mathematical convenience, as we have discussed earlier. We use normal equation method or iterative optimization methods like gradient descent, mini batch gradient descent, or stochastic gradient descent to estimate the weight vector of linear regression model. And finally, we use root mean squared error as a measure of evaluation. Let's translate these English sentences into mathematical forms. So data is represented as D. It is ordered pair of feature vector and label for every training example, and there are n training examples. Linear regression model uses linear combination of features to compute the label. In a vectorized form, we can obtain labels for all examples by performing the matrix vector multiplication. So here the label y, which is a vector and it contains labels for all examples, is calculated as a product of feature matrix and a weight vector. The loss function is sum of squared error multiplied by half, and it is mathematically written as j of w. It is function of weight vector w, is equal to half, and this is the difference between the predicted label and the actual label, and this is the difference vector, and we take transpose of this vector and multiply it with the same vector to obtain the loss function. We use method of normal equation or iterative optimization like gradient descent, mini-batch gradient descent or stochastic gradient descent to estimate the weight vector of the linear regression model. And finally, we give RMSE as the square root of 1 over n, the square of difference between the predicted value and the actual value. Hope you enjoyed the linear regression videos, and now that you have complete idea about the linear regression model. Congratulations, this was your first machine learning algorithm. In the next video, what we will do is we will implement each and every component of linear regression model in a Colab notebook, and I will present that Colab notebook in the next video.